Sir Isaac Newton was an English-born mathematician and physicist whose work has had a resounding impact on the scientific and mathematical world. He was born in the town of Woolsthorpe in Lincolnshire County, situated in central East England, on January 4th, 1643. During his teenage years, Newton attended the King's School, Grantham, until 1661, where he continued his studies at the Trinity College of Cambridge University, before attaining a 4-year scholarship in 1664. 5 years later, in 1669, Newton completed his Master of Arts degree before becoming interested in Nicholas Mercator's book on infinite series, which is believed to be what sparked his interest in more complex mathematics. In his later years, Newton had developed a large degree of fame and prestige throughout Europe before eventually passing away on March 31st, 1727, at the age of 84.
Newton's theory of calculus is extremely prominent in the field of engineering. Without Newton's theorem, engineers would have difficulty solving problems in all areas of engineering, from civil to mechanical, even from electrical to biomedical. Calculus would be needed. Newton's theory of calculus was instrumental as it laid a foundation for mathematics that is recognised worldwide. Education curriculums incorporate calculus into their syllabuses as the importance of it cannot be overlooked. Calculus is a prerequisite for advanced scientific and mathematical degrees in universities around the world. In these areas, calculus is fundamental in understanding complex concepts. Furthermore, calculus is prominent in the finance industry. It can be used to calculate important values in areas such as revenue and profit. As seen in these areas, calculus is extremely pivotal in not only theoretically understanding concepts, but also in applying them in the real world.
Although Newton is perhaps most well known for his studies relating to the laws of motion and gravity, he also advanced multiple areas of mathematics. Of particular importance was his role in developing the basis for modern calculus, alongside his rival Gottfried Leibniz. The first written conception of fluxionary calculus was recorded in the unpublished paper on analysis by infinite series, composed at some point in 1669. In which Newton determined the area under a curve by first calculating a rate of change and extrapolating from this to get the total area. Although Newton knew that there was incredible potential to this theorem, he also knew that there were significant limitations, stating that his work had been shortly explained rather than accurately demonstrated. The modern understanding of calculus is vastly different to that developed by Newton in the 17th century, due to over 300 years of refinement and increased understanding. Calculus is the study of continuous change and is divided into two major subsections, differential and integral calculus. Differential calculus deals with rates of change and the slopes of curves, and integral calculus concerns the accumulation of quantities and the area underneath a curve. Both subsections have multiple applications in science and engineering. For example, they can be used to determine statements for acceleration, velocity, and displacement in the case of constant acceleration. Therefore, Newton, alongside Leibniz, provided one of the most important additions to our modern understanding of mathematics, since it is fundamental to the way we understand the world around us through science and engineering
as a whole. In particular, his discoveries related to calculus have had a lasting influence on many famous mathematicians. One prominent mathematician influenced by Newton was Leonhard Euler, who is best known for his work with mathematical notation and the introduction of exponential functions and logarithms. Euler was also known to work closely with infinite series, using Newton's mathematical discoveries as a foundation for his investigations into the subject. Newton's work with calculus also formed the basis for many other mathematicians, who would then build upon his studies to formulate their own proofs and mathematical discoveries. Such mathematicians include Johann Gauss and Joseph Fourier.